Hello, and welcome back to Summarize Science. Have you ever wondered if you could uncover the fundamental laws of physics using just everyday equipment? Well, a recent paper shows how researchers did something very similar, essentially rediscovering the complex equations for water waves using little more than a simple tank and a video camera. They call this approach GoPro physics, and it's incredibly powerful. The setup was intentionally simple: a small flume of water, a hand-pushed piston to create waves called solitons, and a camera to record them. The first challenge was turning these raw video frames into useful data. Using an edge detection algorithm, they were able to precisely track the water's surface in every single frame, creating a complete map of the wave's motion over time and space. Now for the amazing part: finding the mathematical equation that governs this motion without assuming they already knew it. To do this, they used two completely different and independent data-driven methods. Think of it like two detectives investigating the same case, but using totally different techniques. The first method, called SIND, creates a huge library of all possible mathematical terms that could describe the wave. It then sifts through them to find the simplest, most sparse combination that actually fits the data. The second method, a new technique based on Fourier multipliers, looks at the problem in a different way by analyzing the waves in terms of their frequencies. It directly calculates the relationships between different components of the wave without building a large library first. And here's the stunning result. Both methods, despite their different approaches, arrived at the exact same governing equation. This table shows the coefficients for the mathematical terms they identified, and you can see how closely they match between the two methods. This gives incredible confidence that the equation is a true representation of the physics happening in the tank, not just a fluke of one particular algorithm. What's more, the equation they found wasn't the simple textbook version you might expect. It was a more generalized version that included a significant fifth-order term, hinting at more complex physics than the idealized theories capture. To make sure their discovered equation was actually useful, they put it to the test. They took a new set of wave videos that were not used in the discovery process. Then, they used their new equation to create a computer simulation, starting from the same initial wave shape. These graphs show the error over time, and while not perfect, the simulations did a remarkable job of predicting the real wave's behavior. Here you can see a direct comparison, with the model's prediction of the wave's crest and spread closely following the actual experiment. So, let's recap the important points. Researchers were able to derive a complex physical law from a simple, low-cost tabletop experiment. The fact that two fundamentally different discovery methods gave the same answer proves the result is robust. And they even discovered a subtle, higher-order effect that isn't in the simplest textbook theory. This demonstrates a powerful new paradigm for scientific discovery. Imagine using these techniques to find the governing rules for complex biological systems, climate patterns, or financial markets where the underlying equations are currently unknown. This work highlights a future where data-driven methods, even from simple experiments, can lead to profound new scientific insights. That's all for today. Thanks for watching Summarize Science.